Good afternoon. Hope you're doing well. I'm another weird beast here. I'm from Austria and live in Ireland, so don't ask me why. You can ask me everything about Apache drill, but don't ask me why I'm living there. Pretty much the same weather as here. Anyways, I am a chief data engineer here in EMEA for MapR. And what I want to get you excited, as much excited as I am, is Apache drill. So typically I start off with that kind of question. What kind of workflows do you see in your typical environment, right? What comes to mind for batch processing is obviously Hadoop, right? And if you're familiar with the Lambda architecture, who of you have heard about that? Lambda architecture? Yeah, 1, 2, cool. There's a nice book by Nathan Marks from Manning, Big Data. Read up on that, that's really cool. So if you do these ETL stuff, we heard about that, data warehousing, whatever, you typically would use Hadoop, right? OLTP, of course, HBase, Cassandra, serving layer in the Lambda architecture, typically where you would find that or use that. The Facebook guys, for example, use HBase every time you chat, right? That's actually everything in HBase. Stream processing, Storm, pretty much one of the leading parts there. S4 from Apache, also available. Everything in IoT, Internet of Things, social media feeds, sensor data, whatever you have there, you would use something like that. And speed layer in the Lambda architecture. Good old search, information retrieval, everything based on Lucene, for example, Apache Solr or Elasticsearch. No matter if you're dealing with unstructured documents or semi-structured JSON, or if you must XML, and also from data stores, MongoDB or whatever, you would use that. But what about interactive, ad hoc query at scale? I'm always talking about at scale, right? What about that? Anyone? No, Paulo, you're not allowed to say something? So currently what we have there, and Christian, please don't beat me up, it's Hive and others. That's great, right? You can develop your stuff there. Pretty much SQL-ish, HiveQL. You can discuss how close it is to SQL, but all of them are pretty slow in terms of latency, right? Submit something, you gotta wait till you get your result. So what we really want is low latency. And there are a number of contenders here, and we'll hear about Impala later on. But we're talking about Apache drill, right? This open source Apache project. So just to motivate you a bit, meet Jane, she's a marketing analyst, and she has a deadline. And as we know, deadlines are always yesterday, right? So she has to determine for an upcoming marketing campaign a certain target segment, and her data sources that might be spread over different kinds of data. Oracle might have the transaction data. Cool kids do MongoDB. The user profiles are stored there. And the access log, the web click logs are in a Hadoop cluster, right? And her question now is, well, she doesn't really know what kind of questions to ask. She might have a hunch, right? But she has to deal with these different data sources and has to kind of exploratively figure out what kind of questions to ask to determine this target segment for the marketing campaign. Another one which is slightly obfuscated from a real customer. In the logistics, you might have different suppliers. And again, set up like that, you have a relational database that holds all your supplier data, good old relational scheme. And then you have, in that case, I represented it as JSON log files when which kind of delivery or shipment has taken place, timestamped. And of course, you have these links or relations between the different data sets. And you might have queries like how many shipments in a certain period from a certain supplier and so on. So looking at these two use cases and many more we have identified over the time, we came up with things like, okay, this system we're going to build that has to be able to deal with different data sources, right? We also want to be able to provide different query interfaces there. Real-time low latency is a must, and ad hoc queries are relevant, and not only relevant, but really very important. You Your knowledge about the system changes, the conditions change, so you really need to be able to ask ad hoc queries. And of course, as usual, it has to be scalable and reliable. A bit of a backdrop now. I'm going to go through that very quickly because, as you have seen, next HUC meeting here in June, you will hear about Dremel way more detail as I can do now, but just some highlights there. In 2010, Google published this Dremel paper, and Apache Drill essentially takes these two main innovations here, the multi-level execution of serving trees and the columnar data layout for nested data, takes these two things that Google has been doing with Dremel and has been operating for a while now and offering as BigQuery as a SAS level service. And the two main things, the two main innovations they introduced here are these trees, these serving trees. So the root takes on the query, distributed in the tree, and all these leaf servers essentially look at a part of the data, scan a part of the data in situ, where the data resides locally. And the second bit they did is they came up with this. Let's have a closer look at that. Essentially, nested data structure. In the Google case, it's protocol buffers, can be Avro, Thrift, whatever you have there, plus the schema, right? You need a schema, that's protocol buffers in that example here, taken from that research paper, and some instances. And what you want is you want it in a tabular form, because then you can apply these normal columnar storage compression algorithms and so on. And what they did, they essentially came up with an algorithm that turns this nested data structure into this tabular data structure. And then you can do the standard columnar stuff that relation databases have been doing for quite a while. Not that widely deployed, but there are examples. Of course, it's a research paper, so they had to fill the evaluation section somehow and came up with some nice experiments. Probably not that impressive, some billions, trillions, some terabytes there. But what the main insights really are is, on the one hand, they did the standard MapReduce stuff, then they applied these columnar storage principles on that, and you see already a 10x difference here, and then Dremel that combines the multi-level execution trees with the columnar stuff, and you get another more than 10x speed up there. And then the other question was, how many levels is good for you? The more, the better. Well, turns out to be not really the case. Oops. So they looked at two queries there, and you see from 2 to 3, there is a bit of a change, but then it kind of flattens out. So it's typically sufficient to have two or three levels of that tree. So it's not that the more the merrier, because the overhead in communication kind of eats up your performance gain then. If there are any questions, please do feel free to interrupt me. But for now, back to Apache Drill. Thank you, John. So the key facts, of course, it's, as I said, inspired, the design is inspired by Google Dremel. What we want to make sure, and that's a very pivotal requirement from what we see deployed BI tools speak SQL, and not just some speak SQL, but really standard SQL. So we went for this SQL 2003 support. If you remember, one of the requirements was to be able to deal with different kinds of data sources, relational, Hadoop, Mongo, whatnot. So what you want there are pluggable data sources, right? You come up with your own data source, you should be able to plug it in, and it should run. Pointed that already out, nested data, be it JSON, be it protocol buffers, whatever you have, is treated as first-class citizen. Schema is optional, so if you have a schema, that's fine, we can leverage that. If not, we're going to explore it. And last but not least, it's an Apache project, so it's community-driven, open, and that's my main motivation is to engage you, to make you start contributing to that wonderful project. So let's have a look at a very high level look at the architecture. What you find there in Apache Drill is on the bottom, you have the data sources, and as I pointed out, could be HBase, could be Cassandra, Hadoop, HDFS, MongoDB, relational databases, and here is your favorite specialized NoSQL store, if you want. And on the very top, in the user land, you have the standard interfaces that you kind of expect from the Hadoop ecosystem, a REST interface, command line interface, so you can interact on the shell, and a native API in Java, and JDBC, ODBC, so that you can plug in your BI tool there, right? And I'll come to that in a second. So what's happening there, how Drill approaches that is, you have a source query, and as I said, SQL 2003, no doubt. However, there might be domain-specific languages. You might want to use MongoQL or whatever. Doesn't matter, because the first step is an openly defined parser API that takes this source query and transforms it into a logical plan. And this logical plan is really, essentially, if you serialize it, it's JSON, has the definition of the data sources and the operators like scan, filter, and whatnot. That's something you can directly use. Optimizer, you know what an optimizer does in relational world, and here it takes into account the topology. So if you run Apache Drill not only in a single node but in a cluster, will take that into account, columnar format, and so on, and produces a physical plan that then is executed against the respective data stores. Wire level architecture, essentially, we have a very, or a rather homogeneous, symmetric setup. Each of these drill bits is essentially, has a number of roles, and everything else is done distributed in using this kind of setups. On the one hand, we have Zookeeper, or better say the curator, Netflix curator wrapper around that for the membership information, and for everything else, for the metadata, locality, and so on, we are using a distributed cache called Hazelcast, right? And what happens there is each of these drill bits can play the role as a foreman, what we call it. So it can take on a query, and all the communication between the drill bits is done in memory. So in contrast to MapReduce, where you always go down, you have disk I/O, the mapper writes it down to the hard drive. You might have shuffle, network transport, and then you do the same in Reduce, in the reducer. In our case, we do the entire communication in memory, right? And what happens, if you remember back with this inset for the Google Dremel bit, you have essentially one of the drill bits is then the root server or root node foreman, and that distributes the query down to the drill bits that then actually communicate in the storage processes with the backends, be it relational databases, HDFS, HBase, MongoDB, or whatever. Key features, as already said, full SQL, nested data, optional schema, and the extensibility points. That's something, at least to me, is something very exciting and a differentiator, I would say. All of these parts are extensible, so you can come up with a new kind of query, domain-specific language or whatever. Just write parse against the parse API. You can come up with user-defined functions, can do with the logical plan whatever you like. You can tune and replace even the optimizer if you have a more specific knowledge about the topology, for example, or your columnar format. And also the data sources. For example, there are cases where people want to use, I don't know, MP3 or whatever they have, so they write a scanner against that format then, right? Question I often get is Drill a Hadoop killer? No, it's not. It's complementary, right? And I won't go into details because I'm running out of time, but there is a nice white paper put together by the Google DevRel team, BigQuery. They actually very nicely tell you when to use Apache, not Drill, but Dremel or BigQuery, and when to use MapReduce / Hadoop. The demo, which is available on the wiki, essentially takes a data source. Currently, this is simply a JSON file, and the simple plan, which is the logical plan written in JSON. So far, we didn't have a parser, SQL parser that produces that. And when you run that through Apache Drill, you get that result, and you can really play around with that. There are all these operators defined, and yeah, you can simulate any kind of SQL query, really. And that's, at least to me, the most important bit is be part of it. So what we currently have are these 4 things. You have seen that already: logical plan, the reference interpreter, the basic SQL parser, and the basic demo. However, what we're working on currently is having the full SQL parser, the physical plan and the communication in the cluster, and a HBase and MySQL backend. And we, or I better say, I've taken on that one, will revive this web UI client, which, if you know BigQuery, pretty much looks the same, with the difference that you can plug in different data sources here. So you would be able to run that in your web browser to interact with Drill. And that's one thing that's very important, even if you're not a coder, right? If you don't do Java coding or whatever, you can, and actually it's very much appreciated to be part of that. You can come up with use cases, test data, test queries, and whatnot. So that really shapes the community and the success. The further schedule is in Q2, end of Q2 alpha, end of Q3 beta, and GA roughly by end of year. Shout out to my colleagues, as you can see, all over the place. Some of them map are. We certainly support that activity. And this is the last slide, and I can just point out a number of options how you can interact. Twitter, obviously. If you're old school, you might want to sign up on the mailing list. We have Google Plus Hangouts every Tuesday at 5 p.m. your time, where Google Plus, where you can interactively via video join in and ask questions, or say, I want to contribute to that part. And we have a blog where we, every now and then, every week or so, update on the community things and improvements and plans. Okay, that was pretty much it, time-wise. Okay.